All right, good evening. You're welcome to our fifth lectures in our series of lectures on advanced algebra. Now today, our class is going to focus on the second part of our lectures on the equations. In the last lecture, we talked about linear equations and how to solve linear equations in one variables and two variables. But today, we shall be mostly focused on another type of equation known as quadratic equation. Now, in the previous class, the last class, we saw that a linear equation is actually an equation of this form. A linear equation is an equation in which the highest power of the unknown is 1. So the general form of a linear equation, as we saw last week, linear equation is given as ax plus b is equals to 0. Now, in this case, you can see that the variable here, x, has a power of 1. You know that x raised to the power of 1 is the same thing as x. Usually when the power is 1, we don't usually write the 1. So this is a linear equation. And the reason why it is called a linear equation, the word linear simply means straight line. So if you plot the graph of a linear equation, in most cases, depending on the variable, the equation is going to have something of this form, a straight line, where this is your y-axis and this is your x-axis. But today, like I said, we shall be talking about quadratic equation. And the general form of a quadratic equation is given in this form. Ax squared plus bx plus c is equals to 0. Now, in this equation, you can see that we have two variables here, x squared and x. But you can see here that the highest power of the variable is 2. So any equation in which the highest power of the variable is 2 is actually referred to as a quadratic equation. And generally, when you plot the graph of a quadratic equation, you always have a curve depending on the nature of the values that are attached to the equation. The curve could either be this way or this way. And of course, the point where the curve cuts the x-axis actually forms the solution. So if this is x1, this is x2, the values at this point gives you the solutions to the quadratic equation. So I'm going to take an example, and we're going to see the various methods by which these quadratic equations could be solved. Now I'm going to give a quadratic equation, and we shall solve the quadratic equation using 3 methods. Now, suppose you are given this equation, you are asked to solve 3x squared minus 16x minus 12 is equals to 0. You can see this is a quadratic equation where if we compare it with the general form, which is ax squared plus bx plus c is equals to 0, you can see that a in this case is 3, b in this case is minus 16, and c in this case is minus 12. So that is what we mean by quadratic equation. Now I'm going to solve this quadratic equation using the first method that we shall be learning, which is the method of factoring or factorization. And by the method of factorization, what we are going to do is the original equation that we've been given, 3x squared minus 16 minus 12 is equals to 0. You can see here we have three terms, 3x squared, 16. Okay, this is minus 16x. So you can see we have three terms, 3x squared minus 16x minus 12. Now I want to see a situation where we can convert these three terms equation into four terms so that we can factor the equation. And I'm going to show you how to factor the equation. Now for you to factor this equation, the first thing you need to do is you take the leading coefficient of x squared. The leading coefficient of x squared in this case is 3. So I'm going to take 3 and then I will multiply 3 with the last constant term, which is c. So I'll multiply 3 by 12, and that is going to give me 36. Now the next thing is I'm going to think of two numbers such that when I multiply the two numbers, they are going to give me 36. And when I add or subtract them, they are going to give me this middle number. And those two numbers are 18 and 2. So you can see if I multiply 18 by 2, that gives me 36. And also, if I said 18 minus 2, that gives me 16, the middle number. So it means 18 and 2 are the factors of this number. Now, the next thing I'm going to do is that I will come to my original equation and set 3x squared. Then I will now see how do I combine this 18 and 2 in such a way that it gives me minus 16. So that's going to give me 3x squared minus 18x, then plus 2 minus 12, plus 2x minus 12 equals 0. And this is because minus 18x plus 2x is equals to minus 16x. So in other words, instead of writing minus 16x, I'm represented with these two numbers, minus 18x and plus 2x. So in this case, you can see that I've turned this three-term equation into four terms, such a way that I can factorize or take out the factors. So for me to take out the factors, it means I can group these equations this way. You can see I have two terms here, and here I have two terms here. Now, the next thing I need to do is to check what is common between 3x squared and 18x. 3 is common between, 3 is a factor of 3 and 18. So it means I'm going to have 3. If I take 3x out here, I will only be left with 1x, because if you multiply 3x by x, it gives you 3x squared. Minus 3 will go into 18 6 times. And of course, if you take out x, this x is gone. So you're left with 3x into x minus 6 plus, what is common between 2x and 12 is 2. So I will factor 2 out. If I factored 2 out, I'll be left with just a single x. And of course, 2 will go into 12 6 times. So that gives me equals 0. Now, it is important to take note that whenever you're factorizing a quadratic equation, you can see that what I have here is exactly the same thing as what I have here. So this implies that the factors of this equation is, I will take the first one, which is 3x plus 2. That is 3x plus 2. And one of these equations, these expressions in the variable, x minus 6 equals 0. It then means if you have 3x plus 2 into x minus 6 equals to 0, then it is either It is either 3x plus 2 is equals to 0, or x minus 6 is equals to 0. Now, if you have 3x plus 2 is equals to 0, if you want to solve for x here, it means we are going to have 3x is equals to, we now take this plus 2 to the right-hand side of this equal sign, that becomes minus 2. And for us to solve for the value of x, it means we divide both sides by 3. We divide both sides by 3. And of course, 3 cancels 3, then you are left with x is equals to minus 2 divided by 3. Or here we have x minus 6 equals to 0. This simply implies that our x is simply going to be equals to 6, because we are going to take this minus 6 to the right-hand side of the equation. Now, these are the solutions to this equation, because just like I told you, if you are solving quadratic equation using the graphical method, as you can see here, this curve is going to cut the x-axis at 2 different distinct points. So it means a quadratic equation will always have 2 solutions, at this point and at this point, or at this point and at this point. So it means these 2 values satisfies our equation. And you can always check, if you carry out a check by substituting x equals to minus 3 for x in this expression, when you evaluate it, it should give you 0. The same thing, if you substitute x equals to 6 into this equation, you should have the value of 0, meaning that our equation, our solution is correct. Yeah, Mark, I hope you are following, or is there anything you want me to repeat?
Yeah, I'm following. Yep.
It's all right. So that is the method of factorization if you are given a quadratic equation. Now I'm going to solve this same quadratic equation using the second method. And in the second method, you will see that we are still going to obtain the same result. It does not matter which of the methods you use. So if you are given a quadratic equation and you are asked to solve, you can use any of this method, unless otherwise it is specifically stated that you should use a particular method. So in the next slide, we are going to solve the same quadratic equation using a formula known as the quadratic formula. Now, but before I proceed, permit me at this point to pose the first open class question before we proceed. And the first open class question says, solve (3x squared plus 5x plus 9 equals to 0 using the quadratic formula. Now, what we are going to do, that's the open class question. Now, permit me to solve the previous equation using the quadratic formula. And I think from what I'm going to do, you should not find any problem in solving this. So the same equation says that solve, don't forget, we are still going to solve the previous equation that we've been given, which is 3x squared minus 16x minus 12 equals to 0 using the quadratic formula. Now the quadratic formula says that x is equals to minus b plus or minus the square root of b squared minus 4 multiplied by a multiplied by c, everything divided by 2a. Now this is the quadratic formula. In this lecture, I'm not going to bother us on how the quadratic formula is being derived, but of course there's a proof for this formula. Now what it simply means is that once you are given your quadratic equation, and this is your quadratic formula, all you need to do is for you to identify the values of a, b, and c. And you agree with me, From the general form of the quadratic equation, which we said the general form of the quadratic equation is ax squared plus bx plus c is equals to 0. You can see that our a in this formula is equals to 3. And you can see that our b is equals to minus 16. And you can see that our c is equals to minus 12. Our c is equals to minus 12. Now, all we need to do is just to substitute all these values into all these values. We substitute all these values into our quadratic formula. And this is how it goes. You simply have x is equals to minus b. But our minus b is minus 16. It then means we are going to have minus 16 plus or minus b squared is going to be minus 16 squared minus 4 multiplied by a, and our a is 3, multiplied by b, and our b is, c multiplied by c, and our c is minus 12. Now everything is going to be divided by 2 multiplied by a. So we're going to have 2 multiplied by 3. Now this translates to minus minus will become positive 16. So here we are going to be left with 16 plus or minus the square root of minus 16 squared. If you multiply minus 16 multiplied by minus 16, that gives you positive 256. Now, if you multiply 3 by minus 12, that gives you minus 36. Multiplied by minus 4, that becomes plus 144. If you check that carefully, everything is going to be divided by 2 multiplied by 3. That gives you a 6. Now, this also translates to 16 plus or minus the root of, if you multiply 250, if you add 256 plus 144, that gives you 400. Everything divided by 6. Now let's continue. Let's come to this. Now this implies that our x is equals to 16 plus or minus the square root of 400 is 20, because if you multiply 20 by 20, that gives you 400, and everything divided by 6. Now this implies that at this point we are going to split this expression because it says plus or minus. So we are going to do x is going to be equals to, for the positive, is going to be 16 plus 20 divided by 6. That gives us that x is equals to 16 plus 20. That gives us 36. That gives us 36 divided by 6, implying that x is equals to 36 divided by 6 gives you 6, because 6 multiplied by 6 gives you 36. So that is the first solution. The second solution is going to be for the negative. It means x is going to be equals to 16 minus 20 divided by 6. And of course, 16 minus 20 will give you minus 4. Because 20 is larger than 16, that gives you minus 4 divided by 6. Now, what is common between 2 and 6? 2 will go into 4 twice. 2 will go into 6 3 times, giving you that x is equals to minus 2 over 3, which is the same answer we obtained using the factorization method. We got that x is equals to 6 and x is equals to minus 2 divided by 3. Is it okay, Mark? Hello,
yes,
Mark?
Yes, actually. Yeah, hi.
Okay.
Yeah, do you hear me?
So at least from this solution, what I just did, you should be able to solve this open class question using this quadratic formula. All you need to do is just for you to identify the values of A, B, and C and plug it into your formula, taking note of the signs, and you should be able to get the correct solution. And of course, even after getting the solution, for you to actually be sure that you're correct, you need to plug back the solutions into your quadratic expression to see if that is going to give you 0. If it doesn't give you 0, then it means your solution is not correct. Are we together?
Yes. Yeah. Thanks for the hint. So if the answer is 0, seems the answer is wrong, right?
No, if the answer is 0, it means the answer is correct. Now, okay, let's do a little check. You can see that from this equation, what this equation is simply telling you, Mark, is that, an equation simply tells you that what you have on the left-hand side is exactly the same thing as what you have on the right-hand side, right? Because you are simply saying that the whole of this expression, that is 3x squared minus 16 minus 12 is equals to 0. So let's pick a little exam. Let's do a check here so that you can see what I'm talking about. Let's do a check. So let's pick the first solution. We said that one of the answers is 6, right? Okay, so let's see what we are going to have. If we substitute 6 for x in this equation, it means we are going to have 3 multiplied by x, and we said that x is what? 6. So it means we are going to have 6 squared minus 16 multiplied by x, and we said x is 6, then minus 12. Now let's see what that will give us. Now 6 squared is 36. When you multiply 6 by 6, it gives you 36. Multiply by 3, that should give you 108. So this should give you 108 minus 16 multiply by 6. If you do the maths correctly, that should give you 96, then minus 12. So let's now see 108 minus 96 should give you what? 108 minus 96 should give us 12. Then minus this 12 should give us 0. So you can see that this equation, when we substitute 6 on the left-hand side of the equation, it became equals to 0. It means that 6 is the correct solution that satisfies this quadratic equation. In the same way, if you substitute minus 3 divided by 2 for x in this equation, you should also have 0. You can try that as a homework and check if that is true. Are you okay now?
Yes, sir. Yep.
It's all right. So whenever you solve your equation, you can always check to see if your answer is correct. Because what an equation is simply telling you is that what you have on the left-hand side of this equal sign is exactly the same with what you have on the right-hand side. Or in other words, what this expression is simply telling you is that what number will you substitute for x here such that the answer is going to be equals to 0? And this is the method of solving that. So the first method is by factorization method, as you've seen. The second method is using the quadratic formula. And then the third method we are going to still use to solve this same equation is called the method of completing the square. And of course, there is the fourth method, which we may not do. That is the graphical method, as I highlighted at the beginning of the equation. You can plot graphs of this quadratic formula and see where your curve actually cuts the x-axis. And the point where the curve cuts the x-axis, as you can see in this slide, will actually give you the solutions of the quadratic equation. So can I make progress?
Yes, sir. Yes.
Okay, so we are still going to solve another example, the same question, but using the third method, using the method of completing method of what we call completing the square. Now, and don't forget our equation as usual is 3x squared minus 16x minus 12 is equals to 0. Now, in using the method of completing the square, there are certain important things you need to take note. You have to make sure that the leading coefficient in your equation is equals to 1. And what do I mean by the leading coefficient? The leading coefficient in this case is the number that is attached to x squared. You can see here we have 3x squared, but you have to make sure that you don't have 3 here, that what is in front of x squared is 1. And I'm going to show you how to do that. And then the second thing is that you have to also make sure that you only leave only the terms that contain the variable x on the left-hand side. It then means that this minus 12 will have to be taken to the right-hand side. That is the constant term. And of course, you can see that if you take minus 12 to the right-hand side of the equation, the sign will change to plus 12. And this is how it's going to be. So let's start, first of all, by taking the minus 12 to the right-hand side of the equation. It then means our equation becomes 3x squared minus 16x is equals to 12. So that is the first. We've isolated the variables that contain x and also transfer the constant term to the right-hand side of the equation. Now, the second, I said we have to ensure that the leading coefficient, that's the coefficient of x squared, is equals to 1. And how do we make the coefficient of x squared is equals to 1? It then means we have to divide throughout all the equation by 3, because if we divide this by 3, the 3 will cancel 3 and we'll be left with 1 here. But in solving an equation, whatever you do to the left-hand side, you must do the same to the right-hand side for the equation to remain the same. So we will not only divide 3x squared by 3, but we will divide everything through by 3. So if we divide this by 3, it then means we'll be left with x squared here minus 16 divided by 3x is equals to 12 divided by 3. That gives us a 4. Now, the next step in the method of completing the square is you look at the coefficient of x. You can see this is x, and the coefficient of x is 16 divided by 3. So we have 16 divided by 3. Now, the next thing you do, you take the coefficient of x, you divide it by 2. So this divide by is still the same thing, divide by 2, all over 1. It then means I can convert this to a multiplication to have 16 divided by 3 multiplied by 1 by 2. Of course, this 2 will cancel this 2. This 2 will go into 16, 8. It then means I'm going to have 8 over 3. So once you get the half of the coefficient of x, you can see that the half of the coefficient of this x is 8 over 3. Then we simply pick this half of the coefficient of x and then we square it. And after we square it, we add this value to both sides of the equation, that is to the left-hand side of the equation and to the right-hand side of the equation. And this is what we are going to have. It then means our expression is going to be x squared minus 16 divided by 3x plus, we'll now add 8 divided by 3 squared. We'll also add 8 divided by 3 squared to the right-hand side. So 4 plus 8 divided by 3 squared. Now, if you check the left-hand side of this expression, this left-hand side of the expression is a perfect square. And what do I mean by perfect square is that this expression could be represented by x minus 8 divided by 3 square. And I will leave that as a homework for you. If you pick, what this is simply telling us is that the whole of this number on the left-hand side is exactly the same thing as this. And you agree with me that x, let me do it here, x minus 8 over 3 squared is the same thing as x minus 8 over 3 multiplied by x minus 8 over 3. Because that's what this expression is telling you, that you have x minus 8 all over 3 twice, 2 times. So if you expand this using the FOIL method, you multiply this by this, you multiply this by this, and then you multiply this by this, you multiply this by this, it should give you exactly what you have on the left-hand side of the equation. So this implies that the right-hand side of the expression is going to be 4 plus 8 squared will give you 64, because 8 multiplied by 8 gives you 64. 3 squared will give you 9, because 3 multiplied by 3 will give you 9. Then this implies that we have x minus 8 divided by 3 squared is equals to, if you resolve this 4 plus 64 divided by 9 mathematically could be written as 4 whole number 64 by 9. And of course, if you multiply 9 by 4, that gives you 36. 36 plus 64, that gives you 100 divided by 9. So it means what we have here is going to be 100 divided by 9. Now, the next thing we need to do is to take the square root of both sides in order to get rid of this square. So if you take the square root of this side, don't forget in an equation, whatever you do to the left-hand side, you must do the same to the right-hand side. So if you take the square root of both square, this square root will cancel the square here. So it then means you are left with x minus 8 over 3 is equals to, the square root of 100 is 10, because 10 multiplied by 10 gives you 100. And the square root of 9 gives you 3, because 3 multiplied by 3 is equals to 9. So this implies, let me come this way. This implies our equation becomes x minus 8 divided by 3 is equals to 10 divided by 3. And of course, since we're interested in finding the value of x, so since I said you should take the square root of both sides, it then means it's going to be plus or minus. So we are going to have plus or minus here. So for us to be left with only x here, it means we have to take this minus 8 divided by 3 to this right-hand side of the equation. So this becomes x is equals to, if minus 8 by 3 goes to the right-hand side, it becomes plus 8 by 3. So it becomes 8 divided by 3 plus or minus 10 by 3. So it then means we can work them out individually for the positive and the negative. Then means that our solution x is equals to either 8 plus 10 divided by 3. That gives us 8 plus 10, that gives us 18. And 18 divided by 3 gives us x as equals to 6. Then for the negative, it also means that x is equals to 8 minus 10 divided by 3. This gives us that x is equals to 8 minus 10 is minus 2 divided by 3. You can see we've still obtained exactly the same solution in this case. So generally, in completing the square, the first thing you need to do is you first of all, make sure that you only leave the terms that contains the x on the left-hand side, and you take the constant terms to the right-hand side. And then the second step is you must ensure that the leading coefficient, that's the number that is attached to x squared, is equals to 1. So, and how do you do that? Whatever number you have in the leading coefficient, you use the numbers to divide through the whole equation. And then the next thing you do is that you add half of the square of the coefficient of x to both sides. So for example, if what we have here, let's say is 4, forget about the fact that this is fraction. Let's assume what you have here is 4x. All you need to do is just for you to find the half of 4, which is 2. Then you squared 2, which is 4. So it then means you add 4 to the left-hand side and you add 4 to the right-hand side. And then you proceed to solve. And that should give you your result. Mark, are you okay? Hello, Mark.
Yeah, hi, sir. Yes, yes, I'm okay. So actually, this subject reminds me my college days because UTEL University is my second course. My first course was computer engineering technology. That was a 3-year course. So we had this subject before, and
it's okay.
It helps me. It helps me to refresh
it's
my
all right.
college days. Yes,
it's all right.
Actually, this is a difficult subject for me, but with the help of this program, so it makes me easy. Even though I'm very sorry if I wasn't able to answer the previous exercises on the previous week.
It's okay. You can always catch up. I know you have very busy schedules for your work, but just try as much as possible to see if you can keep up.
Yes, actually, tonight is this week is a Thanksgiving Day in the US, so I'm working on a night shift schedule here in Manila, which is a day shift on the US. So that's why yesterday I was able to do my pending task on this subject. So that's why I was able to submit all the pending on your subject.
It's all right, Mark. It's all right. That's nice to know. I wish you all the best.
Yes, sir. Thank you, sir.
It's okay. Now, having talked about quadratic equation, the next thing we shall be talking before we call it a day is I want us to discuss about what we call radical equations. Radical equations. And we're going to see how we solve radical equations. Now, a radical equation is simply an equation with a square root sign or a cube root sign. It simply means it's still an equation, but only that in the equation, it includes a square root sign or a cube root sign or whatever sign, it could be this in the equation. So that's what we mean by a radical equation. And usually when we want to solve radical equation, we try as much as possible to see how we can get rid of the radical in the equation. And we get rid of the radical in the equation by either squaring or the cube root by cubing. So in other words, if it's a square root, if the equation consists of a square root, we get rid of the square root by squaring. And if the equation consists of cube root, we get rid of this cube root by cubing. In other words, you know that squaring is the opposite of finding the square root, and cubing is the opposite of finding the cube root or the fourth root of an expression. Now, but before we go ahead to solve question, I want to sound a warning or a caveat. You know, sometimes solving radical equations can create solutions which don't actually work when we put them into the original equation. So we actually need to check them very well. And those solutions that don't actually fit in are usually referred to as what we call extraneous solutions. So, but for us to understand how to solve radical equation, let's quickly take an example. So we'll start with a simple example. So assuming you are given an equation of this form and you are asked to solve the root of 3x plus 1 is equals to 4. Now, the first thing you need to do, like I told you, is let's try to get rid of this square root sign. And we can only get rid of this square root sign by doing the opposite of square root, which is by squaring this expression. And of course, because this is an equation which tells us that whatever we have on the left-hand side is exactly the same thing on the right-hand side, in order for us to maintain balance, if we square this side, of course, the left-hand side of the expression, we also need to square the right-hand side of the expression. So this implies we are going to have 3x plus 1 squared is equals to 4 squared. And by squaring this, automatically takes off the square root sign. So it then means we are only left with 3x plus 1 on the left-hand side, which is equals to 4 squared. And 4 squared will give us 16, because 4 multiplied by 4 gives us 16. So you can see that we are left with a very simple linear equation. Now this implies for us to solve for x, we'll simply move this 1 to the right-hand side of the expression where this constant 16 is. So we isolate the 3x. So we have 3x is equals to 16 minus 1. So this gives us that 3x is equals to 15. And for us to find the value of x, it means we divide both sides by 3. We divide both sides by 3. This is because if you cancel 3, we'll cancel 3, we'll be left with only x is equals to 3. We'll go into 3, 1. 3 will go into 15 5 times. This implies that our x is equals to 5. And of course, like I told you, you can always carry out a check to see if your solution is correct. Now, so let's see what the original equation says. It says 3 multiplied by x. And in this case, we've obtained that our x is equals to 5. So it means we are going to multiply 3 by 5 and then plus 1. Let's see what that gives us. 3 multiplied by 5 is 15. 15 plus 1 gives you 16. And the square root of 16 is equals to 4, because 4 multiplied by 4 gives you 4. And you can see what you have on the left-hand side is exactly the same as what you have on the right-hand side. So that checked out correct. So you can always go back to your original equation and substitute the value of x that you've obtained to find out if you are right or wrong. Mark, are you okay?
Yeah.
It's all right. So we are going to pick another example also to see if we can do that. So let's say we are given this equation and you are asked to solve but in this case is cube root is equals to 3. Now you see that in this case, it is a cube root, not a square root. So for us to get rid of this cube root, it means we have to cube both sides of the equation. In other words, we'll raise the left-hand side to the third power. We'll also raise the right-hand side to the third power. So it then means we are going to have Then this will be raised to the third power, and then we are going to have 3 raised to the third power. By raising this to the third power, automatically get rid of the cube root sign, so of the radical. So it means we have x plus 15 is equals to 3 to the power of 3, simply means 3 multiplied by 3, that gives you 9. 9 multiplied by 3, that gives you 27. So it means you are going to have 27 here. So this, again, a very simple linear equation. It then means that your x is simply going to be, you transfer plus 15 to the right-hand side of the expression. That gives you 27 minus 15, implying that x is equals to 12. And of course, you can always check that. So check. You know, the original expression said x plus 15, and you've obtained that your x equals to 12. So it means you're going to have 12 plus 15. So that gives you the cube root of 27. And what is the cube root of 27? What this is simply telling you is that what number is it there is that when you multiply it by itself 3 times, you obtain 27. Of course, this is clearly 3, as we've seen here. Yeah. So you can see that what we have here is exactly what we have on the right-hand side, telling us that our equation is correct. So that's basically what a radical equation it's all about. And I think I'm going to solve the third example, and probably before we call it. So the next example says solve 2 root x is equals to x. Now, the first thing we do is we square both sides. We square both sides of the expression, and this means we are going to have 2 multiplied by root x squared is equals to x squared. 2 squared will give us 4, and this squared will take away the root sign here, so we're left with 4x is equals to x squared. Now you can see that here, instead of a linear equation, it has given us a quadratic equation, because any equation in which the highest power of the unknown is 2 is actually a quadratic equation. So all we need to do is just for us to rearrange this equation in the standard form of a quadratic equation. And this, if we arrange it, it means we are going to have x squared minus, by taking this 4x to the right-hand side, gives us minus 4x equals 0. Now, this is a quadratic equation. The only difference with the original standard form of the quadratic equation is that it does not contain the constant term c. You know that the general form of a quadratic equation is ax squared plus bx plus c is equals to 0. So in this case, you can see here we have x squared, and then we have minus 4x. The only thing is that our constant term c is 0 in this case. So that's why we're left with x squared minus 4x equals 0. And then the next thing we do is for us to factor this expression. You can see here we have x squared, and here we have 4x minus 4x. So you can see that x is common between these. So if you take x out, you'll be left with a single x here, minus if you take x out here, you'll be left with 4. And if you expand this, you should have this. Multiply x by x, that should give you x squared. X multiplied by minus 4, that should give you minus 4x is equals to 0. And of course, for a quadratic equation, like I said, we'll always have 2 solutions. So if you have x multiplied by x minus 4 is equals to 0, it is either, this implies that x is equals to 0 or x minus 4 is equals to 0. So this implies that x is equals to plus 4, because if you take minus 4 to the right-hand side, it gives you plus 4. So finally, our solution is x. Our solution is x is equals to 0 and x is equals to 4. And of course, we can always carry out our check to see. So for the first one, we have 2 multiplied by the root of 0. If we substitute 0, that is going to, the square root of 0 is 0 multiplied by 2. That gives us 0. So you can see, and we said that our x is 0. So you can see that the left-hand side exactly gives us 0. Now, in the case of 4, we can also do that. We'll say 2 multiplied by the root of x. And here in the second instance, we got that x is equals to 4. So what is it? The square root of 4 is 2. It then means we are left with 2 multiplied by 2. That gives us 4. So you can see here, we have 4 is equals to 4, which is our x. So that pans out. Are we okay, Mark?
Yes, sir. Yeah.
It's all right. So at this point, let me give us the second open class question, and then the third open class question, and then we call it a day. The second open class question says, solve is equals to 7. Or let me rewrite it here. X raised to the power of 1 over 4 plus 4 equals to 7. Now, please take note as a hint. X raised to the power of 1 over 4 is the same thing as the fourth root of x. This is a very simple, equation, radical equation that you can solve. So it means, in other words, this expression simply is the same thing as the fourth root of x plus 4 is equals to 7. So this is what I want you to solve. This is just an alternative way of writing that. We're talking about radical equations. So this is still a radical equation, even though I wrote that as an exponent or a power. Now permit me to give us the third open class question before I call it a day. So the third open class question says, solve. It's a very simple equation. Solve x squared plus 7x plus 10 equals to 0 using the method of factorization. So that is that. I would like to hold on here if there's any question, contribution, or observation, because I think I have come to the end of this lecture, except if there's any area that you are still in doubt that you may want me to clear before I take my leave. Mark, it's up to you.
Yeah. Yeah, I'm good. Yeah. So it's a very huge help. So I'm trying to solve this equation number 3. So
sorry, I can get. Okay. Is this the solution to this equation number 3? Is that your solution?
Yes, I tried. Yeah, I tried.
Okay.
I tried. I'm just trying my luck.
Okay. Okay. Let's see. I'm going to keep your solution open, and then let's work it together and see if you get that correctly. And if you get that correctly, I will score you straight away. So you can see here that the coefficient of x squared is 1 here, the leading coefficient, right? So let's multiply 1 by 10. That means you are going to have 1 multiplied by 10. That gives you a 10. So let's look for another 2 numbers such that when we multiply them, it gives us a 10. And when we add or subtract them, it gives us a 7. So it then means we are going to have 2 and 5. So 2 multiplied by 5, that gives you a 10. And then 2 plus 5, that gives you a 7. So it means we are going to make use of 2 and 5 as our factors. So our equation becomes x squared plus 2x plus 5x plus 10 equals 0. So of course, let's factor, take out the factor. So here x is common. We have x plus 2. 5 is common here. It means we have x plus 2 is equals to 0. This implies that our solution is x plus 5 into x plus 2 equals 0. So this implies that x is equals to, okay, this implies that x plus 5 is equals to 0, implying that x is equals to minus 5, or x is equals to minus 2. That is correct, Mark. It's like I've taken you for granted. Maybe I gave you something very cheap. I should have given you something much more harder.
Yeah, thank you. Yeah. Actually,
Okay.
it helps me a lot. So let me know if
Okay.
we have assignment. So I'll just answer it.
It's all right. That's pretty nice. So in your open class question, number 3, you've gotten the score straight away. So I think what you're going to do for the previous, I'm going to take into cognizance, just work the other question quickly and then send it through the relevant link in the learning management system so that I can score you. But I've taken note of the third open class question, and that is excellent. So Mark, I think
Okay.
we've had a very interesting interaction, and I hope that the lecture I've presented has been very, very informative, and I would like to thank you for listening. So good night, and have a good night rest. Are you there, Mark?
Yes, thank you, sir. Yes,
It's
sir.
all right.
Yeah. Thank you, sir.
Thank you too. All right,
Yeah.
bye-bye.
Nice. Thank you. Bye.